Welcome for the lecture video on Chapter 1, Section 6, which is solving linear inequalities. So first, we need to discuss the difference between an equality and an inequality. For an equality, we only have one symbol, and that is our regular equal sign. And when you have a statement like A equals B, what that means is that A is the same value as B, and B is the same value as A. The equal sign can be read in both directions. For an inequality, we have four signs. We have less than, we have greater than, less than or equal to, and greater than or equal to. Now, it's really important that we keep these signs straight. So the way that I always remember is that if it points to the left-hand side, it's a less than. If the arrow points to the right, it's a greater than. However you need to think about it is what I want you to do. You can use what I said, or you can use something that you already know. Now, here, what we're saying is that A is less than B, which means that A is smaller than B. So that's what that sign really means, okay? For the second one, it's A greater than B, which means that A is just simply bigger than B. So we use inequalities whenever we're referencing smaller or bigger, whereas we use the equal sign whenever we have two things that we're going to say are exactly the same value. Now here it's just the same as above. A less than or equal to B means that A is either smaller than B or at most the same value as B. A greater than or equal to B means A is always bigger than B, or at the very least equal to B. So that'll make more sense in a moment when we get to what this looks like on a number line. So let's go ahead and take a look at graphing just a regular inequality. So x less than 2. So remember, this is your x less than 2. We read it left to right, just like always. And what we're going to do is we're going to put this value right in the middle of our number line. So if that's our number line, what numbers go to the right of the middle? Are they bigger or smaller? Right, they're bigger. So we're going to put 3, 4, 5, and 6 on here. And then if the bigger numbers go to the right, which numbers go to the left? Right, smaller. So remember, a number line goes on forever because you have the arrowheads on it. So that means that it will go down to the negative values. So x less than 2. What does that really mean? That means that x can never be bigger than 2, but can x ever equal 2? No, because there's no equal bar here. Right? We're saying x is always smaller than 2. So what we do is we're going to put a circle here at 2. And now we have to decide, do we shade in the circle or do we keep it empty? We keep it empty for less than or greater than because an empty circle means not equal. A filled in circle means equal to. So that's how we're going to use this. Now we know that x is less than 2. So which side of our circle are the values smaller than 2? Right, to the left. So we're going to shade a big arrow all the way to the left and put a big old arrowhead on it. So that way the reader knows that we are always smaller than 2. The shaded region here is where our inequality exists. So the inequality says x is always smaller than 2. So we put an open circle at 2 because we're not equal to it. And smaller is to the left, so we shade to the left. And if you notice, the arrow of the shade matches the direction of the inequality sign. So less than means you're shading to the left, and greater than, which goes the other direction, would mean that we were shading to the right, where the numbers are bigger. So that's another trick you can use to try to remember which way to shade for less than or greater than. Okay, so that's a simple inequality. Now we're going to look at what's called a compound inequality. Compound inequalities look a little bit different, where it means it's two inequalities in one. So the first thing that we're going to have to do is break it apart. And what we do is we start in the middle. So we read from the middle to the left, and we read from the middle to the right. And that's how we get our two inequalities. So we're going to have -1 less than x, that's the left-hand side, and we're going to have x greater than 2. Now you can write it out this way, but what I'm going to show you is the more technically sound way. I said just a minute ago that you want to go from the middle to the left and the middle to the right. So what that means is you're going to take this middle section here and flip it over. So you always lead with your variable like this. So if you notice, x is in the lead on the left-hand side and x is in the lead on the right-hand side. Now if you wanted to, you can write it as I did previously. And these two statements are actually equal to the same thing, because if you pick up this top statement and flip it over, you will get the bottom statement. Inequalities work like equal signs where you can flip, but here the inequality sign is actually going to change the direction it's pointing. So you have to be really, really careful when you're manipulating these. Now I'm going to use this inequality because to me it's easier to see. So now we have two values. We're going to have a -1, which is somewhere over here. And then we have to count all the way up to our next one, which is 2, and we need to go a couple past it. And we need to go a couple past our start, so that way the reader knows what we're talking about. Okay, you always have to leave a roadmap for the reader who's looking at this, just like you do in English. Alright, so the first thing, x is greater than -1. So we know we're at -1. Is it going to be an open circle or a closed circle? Open, because there is no equal bar, correct? So we're going to put an open circle here. Alright, the next inequality, x less than 2. So we're at 2, open circle or closed circle. Open circle. Compound inequalities are really tricky because your compound can either be an or, which means that the graphs point in opposite directions and there is no overlap, or your compound inequality can produce what's called an and inequality, which means that the shaded regions will overlap. We can't go gusto on the graphing until we make sure whether we're looking at an and inequality or an or inequality. So all we're going to do is we're going to shade just like before, only we're not going to shade all the way. We're going to shade in little pieces. So here, x greater than -1. We're at -1. We know it's an open circle because this is just a greater than. Now where is x bigger? To the left or to the right? To the right. So we're going to shade just a little bit to give us a direction. So that way we know which way we're headed. Take a look at the second inequality, x less than 2. Again, we're at 2 with an open circle. And where is x less? To the left or to the right? To the left. Now, if you take a look, does it look like these two regions are going to overlap? As in, are they pointing toward each other? Or are they going to point in opposite directions? So what I really want to know, is this going to be an or inequality where the ends point in opposite directions? Or is this going to be an and inequality where the two sections overlap? Right, this is going to be an and where the sections overlap. So what that means is no arrowheads, and we just shade between the two regions. So if it's an and inequality where the two graphs overlap each other, all we really care about is the region where both graphs exist at the same time. Because the word and means that you're going to complete both parts of it. So if I say I'm going to go home and go to bed, in order for that statement to be true, I have to not only go home, but I also have to go to bed. So we have the intersect of both of those events taking place. And that's the same thing in this graph here, where we have the graph from the right-hand side and the graph from the left-hand side intersecting. But because this is an and, in order for the statement to be true, We want the region where both graphs exist. Now, if I said I'm going to go home or go to bed, in order for that statement to be true, I have to complete only one of those two activities. So if you look here, we shaded just in one direction. And if I would have shaded in this direction, this is an OR with no overlap because there is no intersection of the graphs. That's how I know. So this is an OR where the graphs point in opposite directions. And this is going to be an AND inequality because there's an overlap. Okay, so compound inequalities can be a little bit on the tricky side, just simply because we have to pay attention as to whether we have an OR inequality or an AND inequality. Now, solving an inequality. We solve an inequality just like we do an equation. It's the exact same math. There's only one little quirk. And what this quirk says is that if you multiply or divide by a negative, then you have to flip your inequality sign here in the middle. So I'm going to work through this one and see if you can follow along. First step, you notice that I put the division bar dividing up my problem right down the middle. We still use the inequality sign just like we used the equality sign before. I notice that I have an x on the left and I have an x on the right, and I need to get them together. I'm going to move the 5x because 5 is the smaller coefficient on x. So I'm going to move it by doing its opposite, just like I normally do. 5x minus 5x is 0. That leaves me with 2. 7x minus 5x is 2x. And then I drop the minus 4. Now, when you solve an inequality, you have to ask yourself at every step, did I multiply or divide by a negative? So here I subtracted. Is that multiplication or division by a negative? No. So my sign stays exactly the same. Now I want to get x by itself, so I'm going to add 4 to both sides. 2 plus 4 is 6. Did I multiply or divide by a negative? No, I added, so the sign does not change. And that leaves me with 2x. Now how do I get x by itself? Divide by 2. Okay, now this time I'm dividing, but am I dividing by a positive or a negative? Right, I'm dividing by a positive, so do I have to flip this sign? No. The quirk says you only flip the inequality sign when you multiply or divide by a negative. So 6 divided by 2 is 3. The sign does not change. These cancel and leave you with x, and there's your final answer. 3 is greater than x, or x is less than 3. Remember, these are equal statements. Okay, but if you flip one part of the inequality, you have to flip the entire thing. So think about, you're taking this piece, picking it up, and flipping it over. Okay? So solving inequalities is just like solving an equation. Now, here we have a compound inequality that I want you to solve. In order to do this, we're going to have to break it apart into its two pieces. So remember, I always start in the middle. So I'm going to have 6x minus 10 and 6x minus 10. You always have your middle repeat. So on the right-hand side here, that's just going to be the right half of this inequality, just the way it looks. 6x minus 10 less than or equal to 14. Okay, the right-hand side is always the easy one. The hard one is the left-hand side, and the reason for that is because we're picking up the left half here, the left half of the inequality, and we're going to flip it over. So the 6x minus 10 leads. If we flip it, this inequality goes from a less than to a greater than, and then you have your minus 4. So all that really changes is the order, and then that inequality sign has to flip. And now we're going to solve these just like we did before. So you have to remember your quirk. The quirk says flip the inequality when you multiply or divide by a negative. So I'm going to work through this just like normal. I'm going to add 10 here. And what's nice about this is that the work for the left-hand equation and the right-hand equation is going to be exactly the same. Same steps, different values. So on the left, negative 10 plus 10 is 0, 6x greater than 6. Okay, did we have to flip this inequality sign? No, because we added. We were not multiplying or dividing by a negative. Same thing on the right-hand side. Negative 10 plus 10 is 0. We do not have to flip the sign, and now we get 24. Okay, how do we get x by itself here? Divide by 6. Wait a minute, we have a quirk that says that when we divide, we have to double check that sign. So do we have to flip our inequality sign? No, because we divided by a positive. Very good. So there's one answer. Same math here. We do not have to flip that sign, and we get that. So the compound inequality will give us two values for x, because when we graph, we have to graph both values. And we need to figure out if this is an and inequality with an overlap, or if this is going to be an or inequality where the graphs point in opposite directions. Now that I've had you solve the inequality, I'm going to ask you to graph the solution. So that means that we have to graph this solution and this solution, and we have to put them both on the same number line because they came from the same problem. So this x is the same as this x. Okay? So let me transfer these over. So you have x greater than 1, x less than or equal to 4. So when we graph, we're going to put the left side on the left and the right side on the right. So now that you have your smallest value on the left-hand side and your largest value on the right-hand side, we need to fill in the gaps between the two. And just like always, we have to go a little bit past in each direction so that way our reader remembers that we're going on forever. So x greater than 1, open circle or closed circle? Open, because we're not equal to. And where is x bigger, to the left or to the right? To the right. So we've got that so far. X less than or equal to 4, open circle or closed circle? Right, closed circle because it's an or equal to. And then where are the values of x smaller than 4, to the left or to the right? To the left. So are we going to have overlap for an and, or are our graphs going to point in opposite directions for an or? Right, this is an and, so we shade the region between the two, and this is what our graph is going to look like. And what that means is that anything in the shaded region is going to be a solution to the equation right here. So a solution to this compound inequality will be any value inside this shaded region. Okay? So I hope that makes sense. We're going to go on and look at the or side of inequalities here. But remember, if you have questions, try the homework, follow the homework video, and then make sure that you come back into class and let me know if you still have questions. Okay, solve the following inequality. Now, if you notice, this is not a compound inequality. This is an or inequality. So we're going to do the same thing. We're going to split it up at the or sign and write the left side and the right side and solve for x simultaneously. So we're going to have a 3x plus 5 less than or equal to 11 here. 5x minus 7 greater than or equal to 23 there. Solve for x. So on the left, first things first. Okay, do I have to flip that sign? No, because remember, we only flip when we do what? That's right, multiply or divide by a negative. So there's the first solution. Second solution. Is right there. Now, what word did they use to separate our two inequalities? And or. Right, it's an or. What do we know about inequalities separated by an or? They should point in opposite directions. So when we graph this, there should be no overlap. If there's an overlap, we messed up somewhere. So graphing these is a really good way to check and make sure that you did all of your math right. So let's take a look. When we graph these, remember the word was or, so there should be no overlap. So which of these values that we have is the smaller one? Right, 2. So that's going to go over here on the left. And then what's the biggest value? 6. So that goes on the right. And now what do? Right, we fill in between. So we need a 3, a 4, and a 5. And then just like always, we have to go a little bit past for the reader's sake, so that way there's no confusions. Okay, x less than or equal to 2. Open circle or closed circle? Right, closed circle. What about at 6? Open circle or closed circle? Closed circle. Again, how do we know? Because of the equal bar. Okay, now where is x less than 2? To the left or to the right? To the left. So we shade to the left, and then when you hit the end of the number line, you have to put an arrowhead. No arrowhead means no points. Because remember, the number lines go on for how long? Right, they go on forever. Where is x greater than 6? To the right. So we're going to shade this way. Did our shaded regions overlap at all? No, they didn't. Right? No overlap in between here. That means that we have an or, which is what we expected because we had an or between the two inequalities. So that's something that you do have to watch to make sure that you're doing it right. So here's your homework for this section. Give it a shot. Remember, if you get stuck, check out the homework video. Show up after school on Wednesdays for tutoring, or ask during class. Make sure that you get your questions asked and answered as soon as possible. And as always, these problems came out of the Algebra 2 Michigan edition by McDougal, Littell.